Rationalizing the denominator. Anytime you have an expression in which the denominator is under a radical, it is not considered to be in simplest form. To get rid of the radical in the denominator, you go through a process that we call rationalizing the denominator. That means we want to make it a rational number. Okay. Now, let's look at a few problems where we see how to do this. 4 over the square root of 5. Here, the 5 is under a radical, and 5 is not a perfect square. So our job is to get this denominator to have a perfect square under the radical. So if we already have a square root of 5, if we multiply it by another square root of 5, that would give us a square root of 25. And then the square root of 25 can come out of the radical and become just a 5. So this is the process that we're going to be using. But so that we don't change the value of what we start with, if we multiply the bottom part by the square root of 5, we also have to multiply the numerator by the square root of 5. Because the square root of 5 over the square root of 5 is 1. And anytime you multiply an expression by 1, you're not changing the value of that expression. So that's the y part. Now let's just finish working the problem. The 4 is not under a radical. The 5 is. So that means when we multiply them together, it will be 4 times the square root of 5 in the numerator. Both of the 5's in the denominator are under a radical. So we'll multiply them together under one radical, which gives you the square root of 25. So we end up with 4 square roots of 5 divided by 5. This expression is equivalent to what we started with. It may not look simpler, but mathematically we consider it in simplified form. Let's look at the next one, square root of 3 over 7. This, again, the denominator is not a perfect square, and it's under a radical. So what we're going to do here is try to make it be a perfect square. So I'm going to multiply this one by the square root of 7 over 7. This is the square root of 1. Square root of 1 is 1, so I'm not changing a value. I'm just going to change the way it looks. So that means I have the square root of 3 times the square root of 7 in the numerator, which is the square root of 21. In the denominator, I have the square root of 7 times the square root of 7, which is the square root of 49. But the square root of 49 is 7, so I have the square root of 21 over 7. Now I cannot reduce that anymore because the 21 is under a radical and the 7 isn't. So this would be my final answer. Let's look at one more, the square root of 1/3. To make that 3 come out of the radical, I want it to become a perfect square. So I'm going to multiply by the square root of 3 over 3. So that will give me a square root of 1 times 3 is 3 in the numerator, and the square root of 3 times 3 is 9 in the denominator. So the denominator is a perfect square. I can take it out of the radical, and that would leave me with the square root of 3 over 3.